Jackpot, baby. Welcome back, and as you can tell, my heist was unsuccessful. That was due to the robust security measures that were in place. In today's devlog, we're going to walk through some of the security measures that we have in place here at Budgeteze. So without any further delay, let's get into this!
The cross-site request forgery attack is where an attacker will make a request from another site to your site. This can be a little nasty exploit. Here I've written a little test that attempts to attack an authentication controller. If these attacks are successful, then a user from another site could log in. If this was another controller, who knows what dastardly things they could achieve. Okay, so when we run both of these tests, we're going to see that we get two different results. So let's go ahead and open up our networking panel here. Here in the first, we'll attack using a form. So we'll say user, pass, and we'll submit it. And we'll see here that we're going to get a 415. So what this is saying is that the way we post it back to the server is an unsupported type. And so Budgeteze will not accept that. Well, that's fine, no big deal. Let's just try a normal post with a JSON object. Here, we're going to click this button. We'll see that, we're getting this CORS error now. See, Budgeteze only allows trusted domains to call it. So our API is not exposed to the world, and this helps protect us from a CSRF attack. Cross-site scripting is where the attacker will store malicious code on a site. Generally, this applies to where a user can supply text to a field that gets saved to a database. Now you could be thinking, Travis, Budgeteze doesn't have a public form. A user can only see their own entered data. While that is true, I've read case studies where a stored private XSS attack paired with a CSRF attack allowed some attackers to steal a lot of data. So in our test, we have a div that is being data bound to an input. So whatever we type into this input, like hello world, you'll see that that div will contain that. So what's the big deal? Well, if we type in an H1 here, or H12, and we close that H1, we'll see that now, well, we can most definitely insert HTML dynamically into Blazor. Now that's a problem because we don't want to allow users to insert malicious JavaScript, because then they could use that to expose data, steal user accounts, etc., etc. So let's go ahead and test, see if we can execute JavaScript through an XSS attack. So here we'll create an image tag. We'll set the source to be something that is wrong. And then we'll have an on error. And we'll want to set that to a JavaScript function. So we're just going to do alert. We'll say hello. And then without a doubt here, we are seeing our JavaScript attack here. Now, this one's pretty naive. Now, this one's pretty harmless, but it could have been something much worse. So let's go ahead, let's see if we can paste this into a part of our application to see if our application is currently vulnerable to this type of attack. So over here, we have a month loaded up, June 2021. Here we have a category and with an item called test. Here we'll just paste in our image tag. We can see that it's saved to a database. We didn't see an alert. If I refresh the page, we're going to get our data back here in just a moment. We can see that still no alert. This is great. Blazor is giving us a helping hand. It can already escape raw HTML, as long as you don't cast it to a markup string. The general idea behind SQL injection is to extract additional data from the database by sending a custom SQL query. These queries are created by inserting SQL into query strings or user-supplied data. If you recall, I am using Azure Commerce DB and NoSQL Store. Does this mean that Budgeteze is susceptible to a SQL attack? Like a good lawyer would say, it depends. I've created a test environment where we can test to see if Budgeteze has this vulnerability. If we look at our controller here, we definitely see that we have a SQL statement right here. Now, throughout my entire data access layer for NoSQL, I have queries just like this one. If we go ahead and run the application, we're first going to have to write a ID that will take advantage of our SQL statement in the backend. So we're going to say 1 or 1 is equal to 1. Now what we want to see here is that we're going to have all the data being returned from the partition inside of the database. Now, this definitely isn't good because my application, the NoSQL DAO, has SQL statements written like this everywhere. Thankfully, like SQL Server, Cosmos DB SQL API has a way that you can parameterize the query so you can mitigate a SQL injection attack. So the first thing that we're going to want to do is change my SQL query here. First, we're going to get rid of this string interpolation. Next, I want to add an @ symbol in front of my ID, and then I want to add a list of query parameters. Now, I have a helper method called getItems that allows me to just pass in a list. You have to do a little bit more work on the back end to make this work with your Cosmos DB NoSQL API. Anyways, let's go ahead and say new query param. I'm going to pass in my ID and then the ID text. Everything should be good to go. We'll stop the application. We will save it. I forgot a param. There it is. And we'll go ahead and start it up again. So if I just go back to the statement and I delete everything, we'll see that it all gets taken away. Then if I write the same statement again, this needs to be an OR, we will see that we don't get any results back. Sweet, we have successfully mitigated SQL injection within Budgeteze. Now when it comes to our user authentication, you can use a third-party auth provider or roll your own. Here at Apps by Tap, we care about our users and we don't want third parties having our user data. So we have chosen to roll our own. Now when it comes to password hashing, there are several hashing algorithms to choose from. You have PBKDF2, script, Argon2, and the list continues. We have chosen Argon. It's an award-winning recommended hashing algorithm. Now one of the ways to discourage attackers from brute forcing a login is to have the hash algorithm take as long as possible to compute the hash. In most website cases, that is 1 second. Now we can achieve this with Argon, but we have to configure the parameters that we use for our environment. When I click this button, a GET request is sent off to the server. Now I've modified a desktop Argon configurator to work within a web environment. I've posted this to GitHub. Check the link in the description below. I've done this because Budgeteze is running on an Azure app service and not a VM, so I don't exactly know what hardware my app is running on. Now, when I get my results back in a minute or so, it's going to give me a list of parameters that I can use to configure Argon. Now, Argon takes in many parameters to create the hash, and if any of those parameters are different, the hash will come out different. So if you hash something with 1 meg of RAM versus 2 meg of RAM, different hash. 32 cores or 2 cores, you're going to get a different hash. Once we get the table back, we'll end up testing that. Now the problem with using something like Argon is that when I need to upgrade the hardware of my auth service, I will need a workflow to also upgrade the user password hash. Okay, so we have our results back from our Argon configurator. So we have our processor cores, the amount of iterations the algorithm is going to run, how many megs of RAM, and how long it ran. So we're going to pick whatever's going to get us probably closest to 1 second. Now, this is just on my local machine. This isn't actually running out in Azure. I would want to give the keys away to the kingdom of how my Argon hashing works. So, like I was saying earlier, Argon takes in all these different parameters to compute a hash. If you upgrade the hardware that your auth server is running on, then you're going to need some type of workflow to upgrade your users' passwords to go along with it. But that's a problem for another day. For now, we can just test the mixture. So if we go ahead, try hashing hello world, and we do it with 1 meg of memory, we see that we get a certain hash. And if we try to hash it with 2 megs of memory, we get a very different hash.
Once again, thank you for following along with me on this journey to build Budgeteze. Now there's a lot still left to be developed, and I'll be releasing a CTF version of the site. So if you're a hacker, stay tuned. Now don't forget to drop a comment below and smash that subscribe button. Until then, I hope you have a wonderful rest of your day. Bye.